Let's find the point of intersection by using substitution. This is equation number 1, and this here is equation number 2. We're going to substitute equation number 2 into equation number 1. First, let's divide this equation by 2. Let's have it. We have y equals 4 plus 2x. This is the same thing as saying y equals 2x plus 4. We're going to substitute this line equation, this y value, into this y value here. So plugging it in, we have 2x plus 3 times y, which is 2x plus 4, equals 12. We have one equation and just one unknown variable x. We can do this. We'll use distribution. 2x plus 6x plus 12 equals 12. 2x plus 6x is 8x. And when we throw 12 over, we have 12 minus 12, which is 0. Dividing both sides by 8, we get 0 divided by 8, which is 0. X equals 0. Now that we know that x equals 0, we can plug it into any equation above. We have y equals 2 times x plus 4. So y equals 4. The coordinates of the point of intersection is 0, 4. Now let's try this problem by using elimination. Recall equation number 1. We have 2x plus 3y equals 12. Let's copy equation number 2, written in this form here. So we have 2x plus 4. 2x plus 4 equals y over here. Let's try to align the y's and the constants. So we'll switch positions. The positive y, we move it to the left of the equal sign, becomes a negative y. So we have 2x minus y equals negative 4. So this here is our equation number 1. This here is our modified equation number 2. And we're going to subtract 1 minus 2, the entire equation. Top minus bottom. 2x minus 2x disappears, it becomes 0. The x's are eliminated. What's 3y minus negative y? Two negatives become a positive. Essentially, we have 3y plus y, which is 4y, equals 12 minus negative 4. Two negatives become a positive. We have 12 plus 4, which is 16. Dividing both sides by 4, we have y equals 4. Now that we know what y is, we can plug it into any equation. We can just plug it in right here. It's fine. We have 2x minus y, which is 4, equals negative 4. So 2x equals negative 4 plus 4, which is 0, and thus x equals 0. So we have the coordinates of the point of intersection using elimination is 0, 4. Same answer. How many times do the following lines intersect? We have y equals 2x plus 3, in which the slope m equals 2. And for this second line, let's find the slope. We throw negative 2y to the right, we have 2y, and we have 3x on the left, minus 1, because we throw positive 1 becomes minus 1. Dividing both sides by 2, we have y equals 3 over 2x minus 1/2. This here is the slope, 3 over 2. So the second slope, this is m1, this is m2, equals 3 over 2, or 1.5. The fact that we have different slopes mean that the graphs must intersect. One slope is slightly steeper, one slope is less steep. So by definition, if the slopes are different, there is one point of intersection, one time only. Now for this system here, let's rearrange, we have y equals 2x plus 6 for this second line. Now the first line is divisible by 2, so let's do that. We have 2x equals y minus 6. We throw the negative 6 over, so we have y equals 2x plus 6. Notice that these two lines are exactly the same. And when we have an equation with a y-intercept of 6 with a slope of 2 right on top of each other, these lines are coincidental. There are an infinite number of solutions. They're always on top of each other. So we'll say that the lines intersect an infinite number of times. Now let's focus on the third system. We see the slope here for this line is 2. Now what about this line here? Let's divide by 2. We have y equals 2x plus 3 over 2. We have the same slope, 2, but different y-intercepts. So essentially, we have the first line with a y-intercept of 5 with a certain particular slope of 2, but the second line has a y-intercept of 3 over 2, or 1.5. So the second line is just underneath the other line. They're not touching, they're parallel. So we'll say there's 0 solutions, they never hit. Finally, we have this line, y equals minus 2x plus 4, rearranging. We see the slope here is negative 2, and we can even sketch it. We have a y-intercept of 4, and a slope of negative 2 means down 2 and 1 to the right. It's a downhill graph. And what do we mean by x equals negative 2? X equals negative 2 is a vertical line running up and down with an x-intercept of negative 2. The fact that these lines have different slopes means that there's only one point of intersection. It's okay that this slope is undefined. It's a vertical line. These lines still hit only once.